In the previous class, we have started the chapter gradient, divergence and curl. There we have learnt about how to calculate grad, divergence and curl. Now we will be discussing about few properties. So there are total 12 properties have been given. If you check the Ghoshmaiti book or Spigel, whatever book you you are following, there are total 12 properties where today we will prove some of them. Okay, so the proofs are very easy, at least the preliminary or the first proofs. So if you take one, say the first property we are taking, that is grad of f plus g, where f and g two functions equals grad f plus grad g. Proof is very easy. So if you take the left hand side, what does it mean by grad f plus g? It is I del del x, j del del y, k del del z, then f plus g. So I cap del del x of f plus g, then j cap del del y of f plus g, similarly k cap del del z of this thing. Okay, now this part we can write I cap del f del x plus del g del x, then j cap del f del y plus del g del y, similarly from k cap also. Okay, now take the first component from each of the brackets. You will get I cap del f del x plus j cap del f del y plus k cap del f del z. Similarly, if you take the second components, you will get I cap del g del x, then j cap del g del y, k cap del g del z. Okay, now if you take common f from here, we are getting I cap del del x plus j cap del del y plus k cap del del z f. Similarly for the next term, okay, this is our nabla operator or grad, so this will give you grad f, and the next part will give you grad g. Okay, this proves the property. So this you check, it's very easy to prove all this properties. Similarly, you have to prove for divergence also, that is divergence of f plus g will be divergence of f plus divergence of g, that is like this. Property number 2 will be divergence of f plus g, two vector functions will be divergence of f plus, here also, plus divergence of g. Proof is exactly same, similar proof, just put the value of this grad function, how to calculate their divergence, and then by putting the formula one by one you will get the result. Similarly, we can say it for curl also, that is nabla cross f plus g will be nabla cross f plus nabla cross g. Okay, so these are very preliminary and simple properties. Now we are moving to next property, say nabla fg, that is two functions, their product equals f nabla g plus g nabla f, that is grad fg equals f grad g plus g grad f. So what is the proof? Taking similarly the left hand side, starting with grad fg, that means I cap del del x plus j cap del del y plus k cap del del z over fg. Okay, open the bracket, I del del x of fg, then j del del y of fg, k del del y z of fg. Okay, now what is its formula? Differentiation of two product, that is UV rule. So it will give you del f del x g plus del g del x f, right? Similarly from the next two terms also. Okay, now if you consider all this, if you take common g from here for all the first terms, if you consider all the first terms of three brackets, what will you get? You will get I cap del G del X del F del X G plus, then next one is J cap del F del Y G, then K cap del F del Z G. Similarly, this is for the first term of each bracket. Similarly, you will get few terms from the second terms of each brackets. Okay, now check this one. You can take common G from here. So we can write it like this: I cap del del X plus I cap del F del X plus J cap del F del Y plus K cap del F del Z, then in here G. Now what does this means? This means grad F, right? And then G. Got it? Similarly, from the next term you will get grad G, then F. Okay? So this is how to prove this property. Moving to the next one. Next property number 4 say that is curl of grad F equals to 0, and another one is divergence of curl F equals to 0. Prove it. Okay, for any function f. So let's start it. Let's try to prove the first one, curl of grad F, starting with the LHS obviously. That means this cross grad F, right? Now it means this one means I cap cross del del X of F plus J cap cross del del Y of F plus K cross del del Z of F. Oh, so sorry, not this thing. Oh, curl of grad F, right? Curl of something. That means what we can write? That is I cross del del X of that thing, that is grad F, right? Then J cross del del Y of this thing, plus K cross del del Z of this thing. Okay, now take the first term. Okay, if you take the first term, we are expanding it. So what will we get from that first term? We will get that I cap obviously, I cap cross del del X of what is grad F? It means I cap del F del X plus J cap del F del Y plus K cap del F del Z, right? Now moving that del del X over this, what will we get? I cap cross I cap, that will become del to F del X2 plus J cap del to F del X del Y plus K cap del to F del X del Z, right? Now opening this bracket, so I cross I, its result will be 0, that is 0 vector, plus I cross J, that will give you K cap. So K cap del to F del X del Y. Then I cross K, that will give you minus J cap del to F del X del Z. Okay, so by expanding this first term only, you are getting this result. Okay, similarly you need to expand the second term and the third term also, then add these three terms, then you will check the result will be 0. Okay, so this is the proof of the first property, which is curl grad F equals to 0. Now moving to the next one, which is divergent of curl F will also become 0. Okay, so we need to prove the divergence of curl F equals to 0, starting with the left hand side. So this means divergence, that is dot product with the nabla operator. So dot nabla cross F. Okay, that means it will give you I cap dot del x of this thing plus j cap dot del y of this thing plus k cap into del z of this thing. Okay, now we are starting with the first term only. Let's try to expand it. So I cap dot del x of this thing, that will give you I cap dot del x of, what is this means? This means I cap cross del f del x plus j cap cross del f del y plus k cap cross del f del z. Okay, now take this part, opening the bracket and take this part. So what will you get? I cross, now you check this part, this is dot and cross, that means box product, right? And we have known about one property of box product, that this dot and cross can be interchangeable, right? So we are interchanging it, so we are getting I cross I, that means this dot del to f del x2, right, plus I cross j dot del to f del x del y plus I cross k dot del to f del x del z, right? Now the value of I cross I will be 0, 0 vector, then 0 vector dot some vector which is obviously scalar 0 plus I cross j, its value will be k cap, so k cap dot del to f del x del y. Okay, and from this here I cross k, its value will be minus j, so minus j cap del to f del x del z, f is a vector, okay, dot, there is dot product between them. So this is the result you got from the first term. Similarly, you need to calculate from the second term and the third term also. Okay, then add these three terms, the answer will be become 0, because all the similar term will got cancelled out by plus minus. Okay. Moving to the next property. Next we have another very important property, which is, say example 6 I guess, curl cross curl f. We can say sometimes it as curl f, the same thing. I'm just writing it using the operator. That value will be grad divergence f minus nabla square f. Okay, that is curl f equals grad divergence f minus nabla square f. You need to prove it. Proof is exactly like the previous one. Just take the left hand side, start by putting the value and how to calculate the operator's value and all. You all know that. Just put it, calculate it step by step, you will get the result. Okay. This is how we prove all the properties using nabla operator. Next, let's solve another one. Example 7. It is saying that if a vector equals 2yz I cap minus x square y j cap plus x z square k cap, and b vector equals x square I cap plus yz j cap minus xy k cap, okay, and phi equals 2x square y z cube, then find a cross nabla over phi, both are vectors, and a cross grad phi. Okay, then find this one and this one. Okay, this two. The vector a, b, b I haven't used. There were another examples also using b. So leave it, we just only need a. The vector a is given. We know the nabla operator and the function phi is also given. We have to calculate these things. So let's start with the first one. That is, we need to calculate the value of a cross nabla phi. Starting with left hand side. Okay, that means a vector means 2yz I cap plus where is a vector, okay, not plus, minus x square y j cap plus xz square k cap cross nabla operator, that is I cap del del x plus j cap del del y plus k cap del del z, this whole thing over another bracket over the function phi. Okay, now you need to calculate it by using the determinant because it's a cross product. So compute the determinant. Phi is here, I cap, j cap, k cap. This is 2yz minus x square y, xz square, and this is del del x, del del y, del del z. Okay, so if you expand the determinant, I'm only calculating the first term. Okay, so first term will be I cap, then this thing minus this thing over phi. Okay, so in the next step I'm writing the first term only. You have to calculate all these three terms. So in the next step, if you write down the first term only, what will you get? You will get minus x square y del phi del x plus xz square del phi del y I cap. Okay, plus something into j cap by expanding the second row and third row, something into k cap. Okay, now calculate this thing. We already know the value of phi. What was phi? Phi is 2x square yz cube. So calculate the value of del phi del x. Sorry, that one will be del z. Right, this is using x. So del phi del z. Calculate the value of del phi del z into x square y. So you are getting for the first term 6x to the power 4 y square z square plus using the value of del phi del y, we are getting 2x cube z to the power 5 I cap. Similarly for the next term also. Okay, so by getting this two, we will get the result. This is how we compute the value when compute the examples when the value of the functions are given. Similarly, you can solve the number 2 also. Okay, so you take any of the book, either Ghosh Maiti or Spigel. Plenty of examples has been solved there, and a huge amount of examples is given in the exercise. Try to solve all of this. Okay, all of these are important and quite similar also and quite easy. If you opt any difficulty in solving it, you can contact me.